That's actually that's where the row echelon form becomes really important and effective, because when the system becomes huge, and the one which is here is not really that huge. It's very small, in fact, in comparison to the systems they consider in the industry. But still, even this one, it's harder to do in the ad hoc way, whatever way you might have. So this one was, you were looking at two planes like this there. I mean, like it's the example on page 19, which is marked CP. They look at the two vector equation like this. I already put them in the vector form. I replaced the vectors which are given there with my notation like this: A1, B1, C1, and A2, B2, and C2. I'm already making some shortcuts. Well, I think actually the vectors themselves, I didn't put here on the slide the vectors, the content of that vectors. So I hope you have the printout in front of you. Let me just. Normally, we have a special name for these ones too. We call them, everything which has more than two parameters. Two parameters is plane, but everything which is higher than that, we call them hyperplanes. So in fact, the proper name will be hyperplanes. So these vectors are R4 vectors, and these things we call them hyperplanes. But it's just terminology. I still like the hyperplanes more than planes. We have to discuss intersection of these things. And we can do that. This time, because I hope you get already the grasp already the concept what we do when we consider this kind of vector equations. What we have to do, I imagine you know it well. I imagine you more or less understood what we did before. All we have to do, we have to equate this thing to this thing, and then from that equation we have to extract the augmented matrix. And that's, if I do that, every vector here will be the column in that matrix as it is, and every vector here will be the column in that matrix with the negative sign in front of it, right? Because we need to take it on the other side. Do you agree with me? So if I now put this augmented matrix in front of you, the way it was, it will be like this. And I'll put this in the vector form. Look at this. First column of the matrix will be A1, second will be B1, C1. Next will be negative of A2, negative of B2, negative of C2. What will be the right-hand side of my augmented matrix? 0. So we will look at the augmented matrix like this. At this stage, the actual thinking is finished. That's why the row echelon form approach becomes a routine approach. All we have to do, we have to sub in the components of your A vector, the components of your B vector, the components of your C vector, and all of them, and take the resulting matrix to the row echelon form. This matrix will be rather big. You don't have to do it by hand. I don't think anyone here will be testing this kind of skill, or will give you this kind of big matrix to test when it comes to test or exam. We all have reasons, like there's no point in that. So you don't have to copy that. I have a matrix here. Well, I made an effort and I put this matrix here. It's the whole matrix there. In fact, I think the reduction to the row echelon form of this big matrix, it is in your solution helper. It's just because this file, I generated this file like automatically. I didn't type this all in. I'm not crazy. Yeah, so you don't have to copy that. You can refer to the solution helper. The solution helper tells us that if I take this to the row echelon form, you can see this in the row in the solution helper. In fact, if you're confident with Maple, you probably know by now, Maple can help you with that, right? The result of the row echelon form reduction will be this matrix. Of the row echelon form reduction, which I use in the solution helper. Here you can identify your pivots. I have my beautiful red, this time not a circle, oval and I made it oval just to cover this negative 60. That's the only reason I made it oval. Here's my pivots, and we can now assess what kind of solution we're looking at, right? We're looking at the solution which has two non-leading columns, which means we have to parameterize these columns the way we parameterized them before. When we parameterize columns with two parameters, the result will be plane, and this time it will be the plane in the sense we discussed plane with you. So what happens in this example, intersection of two hyperplanes ended up to be a plane, normal, two-dimensional plane. And that's all we have to discuss about this example. Homogeneous system of linear equations is the one which is of this form. I made it really big. It's not supposed to be this big. It's, I mean, like homogeneous. It doesn't mean it's huge.